Hi all. Now I was going to explain big data and analytics and applications ICP5. Okay, first of all, let me share my screen. So this is my ICP. This is my question. What I need to do is I need to perform classification on the images that we had used in the ICP4 by using that data ICP410. So what I need to do is here I need to change some hyperparameters like approach batch sizes. So whatever the parameters we'll be using in the model, so I need to change those one, and whatever the logic and whatever the conclusions I got from it, I need to explain here. So in the same way, after training the data and testing the model, so finally I need to take 5 images from the browser and then I need to test for that model. Okay, so let me share my screen. Okay, this is okay, let's proceed. So here firstly what I was doing is whatever the libraries we are using in this model, I was inputting matplotlib, lib, numpy, tensorflow, pill. This is for the image view, tensorflow, keras, like everything whatever we will be using we had imported in the libraries. And the data set, what I said is we are using CIFAR10 data set. This is the default data set present in the keras. So you will be having 10 classes: so airplane, automobile, bird, cat, deer, dog, frog, or truck. Okay, so here what I will be doing first, we will be loading the data, C14 data. So as we are aware that keras is some default function having some advanced advanced functionality, like when we are loading the data, it automatically splits the data for training and testing. So this is the case, it is done. So here when I was loading the data, the data is by default it got split as we are using keras library. So here I was printing the size, everything. So okay, my train data will be having 5,000 images. Each image will be having 32 to 30, 32 by 32 size, pixels, and 3 here indicates the channels RGB, as it is a colored image, so that's why it is 3. And in the same way, label train shape, here you can see it is 500, as we all know, 5,000 images, and one is nothing but the image name. It is just a text, so that's why the channel will be 1. So here I was just printing the data how it looks like. In the same way, the label test I was also printing. So I was randomly printing the data what it is present the label trend. So here when in the index 0, we will be having 6 in the sense, index 6 in the sense, here you can see 0, 1, 2, 3, 4, 5, 6. The frog data set is present under label train 6, under label train 0. Okay, the frog name is, the frog text is present for that label. So I was randomly giving the image height and the width as 32, 32. So here just I was plotting the images to see what are the images present. Here you can see the horse, the shape, or everything. So what I was doing is, so we'll be having the data here. So it is like some, you can see the pixels at 220, 222, 32, the image pixel. So when we are performing this performing this classification, it is difficult for the model to analyze, uh, because it will be some more complex to the model. Yes, because we will be having 255 like that. But actually this model, what it will do, it will be normalizes the data. See, what it will do, the size is 255, means it is in the range 250 like that, the pixel size. But it will be difficult for the model to perform the task. So what here we will be doing, we will normalizing the normalizing the data. So it will be converted to vectorization from like 0 to 1. So it will be easy for the model to perform the task. So here what we will be doing, firstly we will be converting that, first we will be changing the data type as a float, and we will be dividing that data by 255, so that it becomes the data in the range of 0 to 1. Yeah, so this is the test we have done here. And we can also use encode, one hot encode. One hot encode in the sense just you will be converting that data into 0 to 1 format encoding like. So right now the actual task we'll be doing here. So we actually we will be having 10 classes, right? So num classes we are defined as 10, and then model we will be using sequential function model, in which here you can see rescaling. Rescaling is similar to the normalization, as I said. So what we'll be doing, we'll just normalizing the data from pixel size to some random 0 to 1 range. So this is will be done. So as I had already used, so I had commented this one. Okay, now followed by here you can see the convolutional 2D layer with 16 filters, and then 3 by 3 size padding will be the same. Input size you are giving image head as a different 32 32, 3 filters, 3 channel, and activation is reload. So the next layer we will be defining, we will be having the max pooling 2D. It will just reduces the layer size. It will just reduces the image complexity. Again we'll be doing, we can do how many times as we want. It depends upon the data what we'll be using. So max convolution 2D, max pooling 2D, max pooling dropout. Here we will be using dropout layer. With actually we can if you won't use, if you're not use dropout layer, it will give the data, it will give the result. But as we are using hyperparameters, if you use 0.2, firstly we will be using 0.2, what the prediction will be, and then we will be using flatten. Flatten is nothing but the all the image data will be taken into one dimensional array. Okay, and then dense layer, dense 128 dense layer. Here will be num classes as we are having 10. So then and then we are combining the model. We are using Adam algorithm, and then loss function will use sparse categorical cross entropy. The matrix will be using accuracy. So finally we are looking into the model summary. So here you can see whatever the layers, what are the filters we had applied. So you can see convolution 2D max pooling, convolution 2D max pooling 2D. So you can see 32 32 16. So when applied max pooling, it will reduce half of the size. Okay, so 32 becomes 16 16. But convolution 2D, you can see here it is same because we had applied padding equal to same. So that's why it is convolution, the size is same. If you remove this thing, it will be reduced to it will be reduced, means it will become 16 14 14 like that. Okay, so here the parameters is approach is equal to 10, batch is equal to 30. Approach where that approach is not approach is the one forward pass like that. So how many times our data should be trained? So 10 times data should be trained. So that's why you use approach here, and the batch is nothing but batch is equal to 32. Each iteration will be having 32 images. So here you can see. Here you can see the approach equal to 10, and the iteration 1 by 6 iteration will be having, and each iteration will be having the batch size 32 images will be having. So can here now our model is now the model is fitted. So I had used the fit function to get the model to be 10. The image train label 10, approach batch size, and the validation data equal to image test label 10. So we have performed the task. So here you can see the accuracy, how the data is trained. So you can see that the training data is 10% and testing data is 10%, which is very bad. So as we had these are the hyperparameters you use approach 10, batch 32, and then densely at 0.2. Along with that, here you can see the loss function we use sparse categorical percentage. We'll discuss more here going forward this thing. So I was plotting that data. Here you can see the loss 2 point, it is in the range to the accuracy 0.1 value, loss 2.3 value, accuracy 0.1024. Like that, here I am plotting in a bar graph. So here you can see, so blue indicates the training accuracy and the yellow color indicates the validation accuracy. So here the accuracy, it is uneven. In training accuracy, whenever our model is 10, it should be that accuracy should be in the, it should always go up. But here you can see it is getting decreased and then decrease again. So this is not a correct approach what we had followed. So in the same way, the training loss, blue color indicates the training loss and the yellow color indicates validation loss. Here the data, whenever the validation training training loss it should decrease. However, whenever our model is performing good, we can know that it is performing better. So that's why our training loss should always increase. So for example, take 100 data, so the training is performing good and the loss accuracy will automatically decrease. It goes down. So here you can see the training loss is good, but here the validation loss is constant. So this thing is uneven. So to avoid this thing, so we can say this as a overfitting or underfitting, like that. To overcome with this, what I will be doing, I will be doing some changing the parameters. Okay, actually for the last time we had used 10 for approach, 10 times our data will be 10. So this time will be our data will be 10 for 20 times. The same batch size 64. I had used batch size 64. So here you can see the same thing. And then I had changed the dropout layer to 0.5 percentage. Okay, the dropout layer, what it will do here is, here you can see I had added so actually dropout layer, so it will off some of the neurons and it will stop the data to forward to move ahead to the next layer. Okay, so this is the thing. So here you can see that we are using the same, when we are compiling, we are using the Adam optimizer, and then the loss function we are using is sparse categorical prosentropy. So when I browsed, I came to know that we will be using that Keras will be having some min min abstract prosentropy, like 5 models are there. So here right now we use 2. One is categorical prosentropy and the other is sparse categorical prosentropy. Sparse categorical prosentropy, and here we will be using from Clojit 6, and we'll be using sparse categorical prosentropy. So here you can see here you can see actually this will be having some different. Sparse categorical prosentropy will be used for we'll be having the classes. So for example, we'll be having 10 classes and each class will be having only that set of data. But in just a categorical prosentropy, we'll be having we'll be having the class in the same class, we'll be having different data. So that's why, but we are using 10 classes and each class will be having some the same data with respect to the class name. So that's why we'll be using the sparse categorical prosentropy. So here you can see the dropout layer we added 0.5 percentage. So the same thing it is performed here, and then finally our data is trained for 20 times, and then the batch is having each iteration will be having 64 images. And the same it is got trained, and you can see the accuracy here. The training data is accuracy 84 and the testing accuracy 74. So here you can see, we can see that our data is trained perfectly, not up to the mark, but 75-80% somewhat accurate result. So here I was displaying the same thing in the bar chart. Here you can see that as I told, the training should always increase. And in the same way, validation accuracy also should go up with respect to the training accuracy. And whenever we are performing the task, and the loss should be always goes down. So here you can see the same way training loss goes down, and the validation loss also goes down. So in the exercise, you can see this is the approach, and this is the loss, and then this is the accuracy on the y-axis. So finally, what I will be doing. So here here you can see the 4 parameters I changed, like approach, batch size, dropout, and then loss function. So whatever, I was taking some random 5 images from the internet, and then I was passing that data to my model to see whether my model is working fine or not. So these are the 5 images I had used, and then you can see here the 5 images. So here it is airplane, car, dog, horse, sheep. So when I train this data, you can see it belongs to airplane, belongs to automobile. It belongs, the third image belongs to dog, and fourth image belongs to horse, and the fifth image belongs to sheep. Finally, I was saving this data. If you are performing for the next time, it will be easy to not to lose the data. Means every time, instead of running every time the each command, each shell, if you execute this, the data will be there, and we can continue from the next step. So also here I paste some Here you can see I face some challenges I face, like pairs categorical quotient tokens, pairs categorical quotient. To be this thing, the loss function I face somewhat difficult here. So I need some more clarity on this. That's all. Thank you.